What up, athletes? Whoop whoop! All right, this is 7.2, and your learn. I will solve systems of equations. Solve systems of equations using substitution. Using substitution. Ooh. Okay, this is 7.2. Here's your warm-up right here. Take a minute and do it. Again, pause this because I'm not waiting, clearly for the video for you to do it. Just pause me and then I'm going to work it out. Ready, set, and let's roll. Okay, so right here I see x plus 4y equals 10. It says solve each equation for x. So I'm just going to subtract 4y over. Now, normally with y equals mx plus b, I like to put the x in front, but honestly, we're not doing that, so don't really care. I'm just going to have x equals 10 minus 4y. Now, if I was solving for y, I would go the other route. I'd always put it in mx plus b form. Okay, let's try over here. Solve for x minus 5y from both sides. 4x, that's gone, equals 16 minus 5y. Again, divide both sides by 4. And I mean, you've got choices right here. So this simplifies to 5 halves x, or I'm sorry, excuse me, 5 halves minus 5 fourths y, which is, so we can get that x equals 5 halves minus 5 fourths y, or you could write this as a decimal, 2.5 minus 1.25y. So that's really your choices right there. I'll let you decide. And now, when I'm solving for y, I'm always going to put it in mx plus b form, because that's only going to help me, right? Okay, so add x to both sides. Gone, negative y equals x plus 1. Multiply both sides by negative 1. And what do we get? Distribute that through. I get that y equals negative x minus 1. There we go. Probably should circle my answers. And then last but not least, I'm going to add x to both sides, not the y. Add x. Again, I have negative 5y equals x plus 12. Divide both sides by negative 5. And I get what? There's a 1 in front of there, so I'm going to have y equals, that crosses out, negative 1/5 x minus 12/5. I'm just going to leave it like that. No need for the decimals on this one. Okay? And that's the deal. So that's your warm-up for today. Now we're going to go on to our vocab, which is substitution. And we see that substitution is, sorry, I have another screen I'm looking at over here for some definitions here. A process of solving the systems of equation. A process of solving a system of equations in which one equation is solved. One equation is solved for one variable in terms of the other. A lot of times these definitions don't make sense off the bat. It's because we use a lot of technical jargon. In terms of the other. So a process of solving a system of equations in which one equation is solved for one variable in terms of the other. Okay. So take a moment again, pause this at any point in time so you can write everything down. Sorry, I don't have better handwriting. It's not quite doctor level, so we are there. Awesome. I'm going to move up. I want to look just right here at this. We know how to graph equations. In last lesson we did solving by graphing. So let's graph these two equations that are in mx plus b form. So I know that my start value, well, let's fill out. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I like to make sure our graph looks tight, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, negative 5, 6, 8, 9, negative 10, and 1, 2, 3, 4, negative 5, 6, 7, 8, 9, negative 10. Okay, we've got our graph labeled and filled out. You can't really see it. It's hard to see, but it does say X and it does say Y right there. All right, so what is our start value? For the first one is 6. It says start at 6. And then it tells me right here to go down 2 over 1, right? Negative 2, down 2 over 1. And I can do that a few times. Down 2 over 1, down 2 over 1. You know how I do it. I like to just go several times. And it usually helps me in solving these systems because sometimes they meet up real nice. And of course, we got to label it. Y equals negative 2x plus 6. Got to label them so we know what's going on. Then we have 1/2 x minus 3. Well, that's going to start at minus 1, 2, 3. And 1/2 tells me to go up 1 over 2. Up 1 over 2. That's interesting. Notice they don't meet. Up 1 over 2. Up 1 over 2. Awesome. This is the equation. Y equals 1/2 x. See what I'm doing there? Minus 3. Pause it for a minute. Get this graphed out. Okay, we're going to keep going. Notice they don't meet at a nice lattice point. In fact, if I were trying to do my, can we find an exact solution? No, we can guess. I can guess. G-U-E-S-S. And my guess would be the point, let's see, x. 1, 2, 3. So about 3. I don't know, 7? That's what it looks like, something like 3.7 on the x and about 1.2 on the y. 3.7 and 1.2 is about, that's my best guess, right? If I'm looking at this point of intersection right here. But that's not exact. So what we're going to try doing is we're going to try using the substitution method. Okay, and before we do that, let's write down our steps for substitution. Okay, step 1. This is when necessary. Solve at least one equation for one variable. When necessary. Solve at least one equation for one variable. Sure, get that written down. Again, pause if you need to. But if I look up here, look at this, guys. Notice how each of these equations are already solved for y. So it's not necessary to do step 1 on these because they're already each solved for a variable, which is y. Okay, let's take a look at step 2. Step 2 says, substitute the resulting expression from step 1. Substitute the resulting expression from step 1. See, I write it with you. Step 1. Into the other equation to replace the variable. Into the other equation to replace the variable. Then solve the equation. Then solve the equation. Okay, so So this is a good deal right here. Pause it again so you can finish writing this down. And I'm going to go up here. So again, step 1, already done. Right? Because we have y equals negative 2x plus 6 and y equals 1/2 x minus 3. Step 2. It says to substitute the resulting expression from step 1. So I'm going to substitute this right here. Negative 2x plus 6. I know that equals y. I'm going to substitute that in for this y down here because these y's, we want to know when they're the same. So I'm going to end up with negative 2x plus 6 equals 1/2 x minus 3. And then it tells me to solve. Since I only have one variable, now I can solve. I want to get rid of fractions. Don't like fractions. Multiplying everything by 2. I'm going to distribute that, right? So times 2, times 2, times 2. Okay, so I end up with negative 4x plus 12 equals, those cancel out, x minus 6. Awesome. I'm going to add 4x over here, because then I can keep it positive, which means I need to add 6 over on this side. And what do I end up with? 18 equals 5x. That's gone. Divide both sides by 5. And what do we get over here? We get that x equals either 18/5 or, what would that be? 3 3/5. So 3.6. I'm just saying I was close for my x value. Okay, so let's take that for what it's worth. Now, step 3. Let's go on to step 3. So we gotta go write that down. Again, pause this if you need to, but let's go on to step 3. Step 3 says substitute the value from step 2 into either equation. Substitute the value from step 2 into either equation. And solve for the other variable. And solve for the other variable. Write the solution as an ordered pair. Write the solution as an ordered pair. Let me remind you, an ordered pair is just a coordinate, the xy point, right? We just solved for x. You know it's 18/5 or 3.6, however you want to do it. Now we're going to take this value and we're going to plug it back into one of these original equations, right? From up here. I'm going to go ahead and do it in the top one. So I'm going to have, mark some of this out, give myself some room, because we want step 3. I'm going to have y equals negative 2, and instead of x, I can put my 3.6. I'm going to put 18/5 though. And then minus, or plus 6, excuse me. And because, actually, you know what, I'm going to do this. I'm going to go ahead and multiply. So when I multiply through, I get y equals negative 36/5 plus 6. Well, negative 36/5 is what? It's going to be y equals 5 goes into 35 7 times. And then left with 1. So y equals negative 7.2 plus 6. Which equals negative 1.2. Look at that. Because it comes out exact, I went to decimals. If it didn't, I would multiply through, get rid of the fraction, and give a fractional answer. If I got a fractional answer, what would this be? This would be negative 6/5. So it could also equal negative 6/5. Look at that. But I want to notice this. Look over here. And I know I put 1.2, but I should have put negative. I was exact on my guess right there. Just telling you, hadn't worked this out ahead of time, just so you know. Didn't have answers in front of me at all. And my y value was on. So can guessing get us there? Yeah, it can definitely get us close. But we can't say for sure if it's exact unless we solve it. And this method allows us to solve it exactly. Awesome. So we've got some examples on back. There we go.